Alrighty, I am now in business. Okay, cool. Yeah, so the stuff that I was planning on covering today, at least two of it is coming out of the Big Science Workshop, which is I know that they do distributed training. I thought they might have been the folding at home people. I'm not 100% on that. Um, but yeah, we have like the largest open access multilingual language model, et cetera, et cetera. Um, and yeah, let's see if they've got any interesting posts lately. Okay, Star Coder, yeah. So it's they tend to post pretty few and far between. Um, but I see Megatron here. I'm not sure if they are sort of the originators of that kind of that sort of collection of strategies. But I do remember, or like one of the papers that I pulled out when I was looking through my papers was Deep Speed MOE, and for some reason in my brain that is like I am associating that with distributed training. So I'll have to double check that paper, but I believe that there is. I think it's either Deep Speed MOE or Hetu MOE. It was sort of one of the early versions of how to do this sort of like distributed training and inference at scale. Um, so I guess we'll just work from left to right, which is I have this little post over at local llama, which was yeah about a year ago, which is sort of when the Petals thing started to kind of kick off. Um, the I think I forget which order it goes in, but Petals and Hivemind are sort of the two early iterations of. Let me see if I can find the GitHub of it that I grabbed. Yeah, are sort of the early iterations of how to do some of this decentralized deep learning. So this is like the PyTorch library, and I think they have, yeah. So this is sort of the underlying dependency of Petals. Is this sort of like Hivemind architecture where we're doing? Let's see. Sorry, I'm just getting a DM. No worries. I'm filling in for you. Uh, but if you wanna come on stage, feel free. I'm just running down what I know. Yeah. So Hivemind is sort of the underlying architecture for a few different use cases here. One of which is Petals, which is sort of the I don't know if you would call it Premiere. I would say the ones that I know of that like people actually use are Petals and AI Horde essentially. Um, Deloco and Depaco are Soda, and Prime Intellect plans to open source soon. I have heard of Deloco. I don't. I think I have a paper somewhere about Depaco, but I remember Deloco. Did they ever release code for that? Does anybody know? I'm not sure. I remember when I was looking at Deloco. Oh, hey, Baco's here. What's up, buddy? The Horde is used on Bittensor, and DeepMind did not open source their code. Yeah, I was not sure how useful Deloco would be. Yeah, I'll shoot you a little invite, Baco, if you want to come on up. Or feel free to just hang out. It's all good. Um, the thing with Deloco, or the thing with Petals, and by extension Hivemind, is what they were trying to do was build a sort of consumer hardware decentralized training platform. So one of the big problems to solve there was that you have an irregular compute topography. So I have like a 3090 and like somebody's old 1080 in their laptop, and then like an A6000 that some like random person just like had idling and decided to contribute. And I need to figure out a way to use all of those machines at the same time to get the job done that I want. Um, Now, Deloco is a much more effective method for doing distributed training, but it can't tolerate a compute topography that is as irregular as these ones do. So there's trade-offs in either end of the spectrum. But I will introduce Mr. Baco here, who has been working on and feel free to um, correct me if I am misevaluating, but more or less a private and sort of redesigned architecture of like a Petals cluster, essentially, has been sort of the main project for you guys lately, right?
Yeah, so it's uh sorry, I got my days all mixed up here.
You're good. No worries.
But the basically what we're building is like an open source implementation of libp2p, which is the underlying technology that underpins Hivemind as well as a number of other different architectures for communicating in peerless networks. And one of the cool things about it is that it is a complete nightmare to work with, but it speaks 19 different languages and underpins a bunch of different Web3 blockchains, including Ethereum and Substrate, which is like Polkadot. If you guys know anything about Web3, that's a whole thing. But it also is the underpinning architecture of Petals and a couple different distributed compute implementations. So we're basically just taking it back to the libp2p layer, and we're building everything out in Rust. We have an implementation of Petals for uh, distributed compute on a blockchain that runs Inference, but we want to actually expand it and have it build and run training as well as interop between different protocols so that you don't have to deal with a lot of the complications of Web3 stuff. But yeah, that's sort of the rundown of what it is.
Yeah, it is very cool, and yeah, I did so. I know we are mostly an AI crowd here, and I am the odd man out for being the resident Web3 weirdo. Um, but yeah, there's to me, it's like it's an interesting through line when you're looking at distributed compute, and one of the like genuine actual use cases for a project that can sufficiently answer the question like why do you need a token in the first place, which is often the thing to ask and have answered for a lot of Web3 projects. And in this case, a lot of the uh, kind in order to make these kinds of distributed networks work, you have to get like you have to um, give people some sort of motivation to like perform one action and sort of compete internally, but only with each other. And you need a sort of isolated market to sort of push those um, to have the necessary like incentive forces pushing and pulling at each other, so you can actually get the thing that you want. Um, but yeah, so underlying is libp2p, which also underpins a lot of other distributed tech, like presumably BitTorrent. I technically haven't double checked on that, but
It does,
it
yes.
does. Okay, cool, cool. Yeah. So libp2p is sort of baseline of Ethereum, baseline of BitTorrent, baseline of things like Petals, baseline of things like Substrate, um, which is the framework that the Polkadot blockchain is built on. And then there is I would note here that Rust libp2p supports WASM as well, which if you've been paying attention to like the sort of web GPU space and sort of the interesting stuff that's been going on with WASM and like leveraging the compute of like the browser container more or less. Um, that there's some interesting implications that work there, and then there's also a few blockchains that do some really interesting stuff with WASM as well. So yeah, I guess that's sort of the through line I had in mind was like libp2p is the start, and from there you get to Hivemind, and then from Hivemind you get to Petals and Horde and a couple other things, and then from Petals and Horde and Hivemind you get to Bittensor and then a few other things like this Prime Intellect link that Mutasham has linked over here in chat. So I guess my thought would be, if what you guys are working on is sort of a re-implementation of libp2p, how does that affect like your implementation of Petals? Are you just like running it raw? Are you re-implementing parts of Petals? What's the
Yeah, so we wound up re-implementing the protobufs, which is like a communication templating, like sort of semi-language, but basically it's re-implemented in Rust so that it can communicate with the OpenAI protocol because everybody and their grandpa wants everything to basically be drop in out of the box for OpenAI because they won the AI wars. Um, and so we're setting it up like that so that it will interop with basically any other AI application for the most part because almost everybody writes it with that implementation. Um, and then the libp2p layer is already written, so we don't actually have to do a ton of work on that end. It's more the interoping communication layer that we're working on right now, and that's just being able to talk from one chain protocol to another, which is more like Web3 kind of stuff. And that's basically we're trying to use that to the reason why we're doing the like I was totally against all this Web3 stuff. I'm like, this is like all a scam and it's terrible. But like what I found
doggy
out is
coin
that
scam? Why we use? That's dumb. Don't need.
what we found out is that it turns out they're all printing money and they have a lot of it. So
There is
it's
that is
it's
also a thing. There are more noble reasons, but that is also a thing. Yes.
but it's a really good way to bootstrap your AI project. So if you have if you're looking for like funding for a project or research or like compute, like there's tons of stuff out there. You have to learn some crazy Web3 stuff, and for the love of God, don't put any money into it. But you can pull money out of it.
Very true. And yeah, one of the sort of interesting things for those is, yeah, like it can be an interesting way to bootstrap an interesting project, and then it can also be an interesting way for the users of that project to have some of them encouraged to do other things and disencouraged to do some collection of things, and then have a different section of your users that are supposed to do something like validate the output of the first users. And it's really hard to do that unless you have these sort of like sophisticated incentive layers that you can throw on top. So in addition to to printing money, that money can also execute code, which can be very helpful in terms of like developing a sort of system that works effectively. So I think the natural question for me is, Petals already has like a public sort of network, and I hear that you guys are sort of re-rigging the libp2p to make the thing that you're building more accessible across like blockchain platforms, but also maybe there's some like interesting stuff to do with WASM and then rebinding it over across to like different languages or architectures or what have you. Um, but so then we get over to the Petals side. Are you guys re-implementing? Like, are you basically cloning
Yeah,
the
we're making
existing
yeah
Petals or making some modifications?
we're effectively forking Petals because uh like we never reached out to them. We probably should have.
Hmm.
But I didn't. Like we're working in the Web3 space, and I find that most AI people are not really interested in that, which is fair. And then so we just decided that like we also have there's like a lot of complications in terms of like politics, open source, and like interacting with the leaders of the blockchain and all this other stuff. So it's a matter of just the simplest thing to do is just to fork it. It's open source. We are giving them full credit for it. So definitely appreciate the hard work and totally open to talking to them if they ever hear about it or are interested. So
Interesting. Yeah.
yeah.
Is there any like interesting changes that you've made to the Petals fork that you think are like solving a problem that Petals has kind of by default?
Using a Rust implementation of it,
Fair point. Fair point. Um,
just because Python.
Yeah, well, cause Python and like, so I'm over. I've got the Petals chat up and running right now, and this is usable, but it's pretty slow. So what I'm curious is like, is there is that like I have an opinion on this, but I'm curious on yours. Is Does it have to be this slow? And
No.
okay, and if it doesn't, how do we make it faster?
Implement it in Rust.
True, very true. Um,
uh, the problem with the example that you're looking at there is that it's running a really big model, and the larger models are not uh, like even on the best systems, like even if you put like a huge amount of compute behind it, it still runs slow. The inference almost always runs slow regardless. So I find that it actually works a lot better if you use smaller models. I find the sweet spot seems to be around like the 8 million parameter models, and then those ones tend to give you like quality results as well as still being at a reasonable speed. Because it's interesting because I think that AI would be more useful if we didn't expect it to have immediate and instantaneous like real time response. Like if we could like give it an instruction and let it go think for a while and puzzle some stuff out and make a bunch of mistakes and correct itself. But we're I guess we just sort of got fed ChatGPT now. Everybody expects it right now. So that's just sort of the world that we work in.
Yeah, I think that well yeah, I think it's a use case thing too, right? Where like there are some things where it would work to have the model think about it for a day and then come back to me with whatever it comes up with, and there are some things that you can't do unless you can do it immediately. Um, so it sounds like re-implementation in Rust to just sort of make the guts of it faster is one option. Another option that or like something I was talking with Mike earlier today, and the idea was that if you can get people to so like how Petals kind of works from my understanding is that like so at a super high level there's a peer-to-peer network, and then for this like inference run, normally it would all be done in the same place, but Petals in some way breaks up the work that needs to get done and then distributes it across the peers, and then when the peers are done processing it, um, sort of assembles it and delivers it. Do I kind of have that right? Is there anything that you want
Yeah,
to
so like
elaborate
that's
there?
the reason why it is effective as a distributed compute system for blockchain, is because it breaks up the layers of the model. Like if you think about the when you're writing an implementation of like a transformer, all the different layers of that transformer, each individual one gets broken into a block, and then that block will receive data, and they basically you can run them in parallel, and you run the data through that individual block, and then the block's returned to the DHT, which is like the centralized control network of it, and then is reassembled and then inference. Um, so the biggest thing with that, with the distributed compute and blockchain, is that miners need some kind of difficult and um, challenging computational task to prove that basically it ties it to the real world, so it becomes expensive and difficult to get, so therefore it becomes expensive and difficult to get. um, and
There is
But
a
the
great
thing is,
talk that goes into how that works in more detail because I know that doesn't make a lot of sense to a lot of people. More,
it's like a
but
weird economic thing.
yeah,
um,
yeah. The moral of the story is that like Bitcoin, the place that you mine Bitcoin out of or any proof of work system, you can't pull it out of the ground to make more of it. The only place you can pull it from is the future, and you get the way that we run the clocks is how much math did you do to get there. So that's sort of the really kind of fuzzy explanation of like how proof of work leverages computation. So far, it's largely been arbitrary computation, but here we have like a potential use case to do
well,
useful computation.
and that's the thing, is it not only makes it difficult and costly to um run the inference, it actually is useful. So then like now you can sell the inference, and then now your coin has some kind of value. So like it kind of legitimizes some of the Web3 things. It's like one of the first legitimate use cases that I've seen with it, and then that I was like comfortable enough to work on. But To answer Sebastian's question, yeah, so some of the layers do feed into each other. So some of them you just can't get around the fact that it has to run in parallel. But the as much of it as possible, and quite a large portion of it actually, is broken up, and it also doesn't do like back propagation. So like we don't know how to do training on it very easily yet. I know there are implementations of it, but we just haven't looked into it yet.
Hmm.
So that's something that we're gonna have to do in the future as well.
Yeah, we had, somebody actually mentioned the primeintellect.ai thing, DeLoco. That is so Petals is largely like you can do a little bit of training on it, and for mostly like PEFT, like so like the really small jobs that you don't have to or like the limitation on your back prop across the network is like tolerable in that in a situation where you don't have to do a lot of the training. Um, but Deloco has a is sort of a different approach to that, which I have the paper sort of on the side, and we can go into that a little bit later, I think. But the yeah, in terms of what do you mean different blocks are processed separately? What specifically? Yeah, that's I think a good question. In terms of the parallelization across the network when you are trying to complete a run of inference, what specifically gets parallelized? Like what is each one of these peers doing?
Like they basically have the reason why it's kind of difficult to run like large lots, like you can't run very many models on this system, because each implementation has to sort of take into account the model's architecture, and then they are basically broken into discrete portions. Yeah, if you actually go to the site, you can see there's a little picture graphic
Oh, really?
um
Which on Petals or like
on the
Petals.dev?
GitHub, on the Git for Petals. Yeah,
Ah, got it. Cool. Go grab.
yeah, the
I'll
Big
throw
Silent
that up.
Workshop, that's it. Yeah,
Hmm.
if you scroll down a little bit,
Cool.
yeah, there's that. So like it basically breaks it into different layered chunks, and it's effectively determined by the model and what things have to run in sequence and what things have to run in parallel. And so the idea is to offload the larger portions that other people can't run onto larger GPUs, and then have you run the smaller portions that you can run on your local machine, and then sort of have everybody working in harmony. The main reason this didn't really take off, I don't think, is just because there was no incentive to have anybody working with this. Like, why would I put my GPU up there? Like, it's kind of like Napster was like a weird. I don't know. I'm probably dating myself, but Napster was a weird sort of not normal case of like human self motivation, or self interested motivation, because everyone was so excited about the fact that you could share music, that everybody just did share the music. It also wasn't like computationally like that, like high of an overhead. But when you're talking about high powered GPUs that cost thousands of dollars and people want to play video games or whatever, there's very little incentive to do that. And so that's also the other reason for the Web3 stuff, is because you pay you use the emissions from the Web3 stuff that you sell the inference from, and then it's all like one happy little circle. The miners get paid, the blockchain makes money, the customers get inference, and everybody's happy theoretically. So, yeah.
Yeah, I think the other thing about Napster that Bloom or that something like a distributed model training network is not taking into account is like in Napster, like I got to like I had incentive, right? Like I wasn't just doing this out of the goodness of my heart. I was doing this because I had music that I care about that I want to go show other people to. And I think LimeWire did it. I don't know if Napster did, but you can sort of get into the peer-to-peer scene and get some like social validation out of that. And then maybe, people are
Hey
starting
man,
to
I was not the pure nerd when I was in high school, because I was the one that printed the CDs that
Yeah,
everybody
yeah.
wanted.
See, so yeah, but if all I'm doing is just like throwing away some spare GPU cycles, like no, there's not cool music that I'm sharing with anyone. Like I just sort of like internally know that like I'm maybe doing a good thing sometimes if anybody uses this chatbot maybe. Um, but the so yeah, it's a lot less. There's a lot less potential to have any kind of incentive to do this at all. The other blocker that I know for why this didn't really take off is because I think like so in this sort of section you have to wait until all of the peers are finished, and then some of them are going to be slower than others. Um, and so in terms of the amount of people that are contributing to a given run, then the bottleneck there can be that like whoever has the crappiest connection and the slowest card sort of drags down the total speed of the network. Is that does that match your understanding as well?
Yeah, so we have like basically like a optimizer that like prioritizes where things go. So that it's basically we don't want necessarily like it's good to have the distributed compute, but like so like we're basically tiering it. So we have things that are like important to have like really like lightning fast speed, and then we have like another tier that's sort of like it doesn't matter if this takes a little bit of time. It's like it's consuming a huge document or whatever. Um,
Interesting.
yeah, so that's going to be the implementation for it.
Yeah, well, yeah, that's interesting. Because yeah, so like as far as I know, the public pedals that the sort of research people sort of launched for everyone to use is sort of a kind of a naive implementation. Like they don't, you know, they just wanted to prove that like we had a research paper and this is a thing you can do. Here you go. Like you know, use this
Yeah,
little
so like a
chatbot.
proof of concept. Yeah.
Yeah, yeah. But sort of trying to take it up to production, um, making those sorts of optimizations, like, okay, how can we decide which job should run where, and like, can we optimize that so that we get better performance is I think like a sort of an underexplored area, and one of those things that I think a lot of I mentioned this at the beginning. I don't know if you were around for it, Baco, but a lot of the ML people that I know are like, yeah, distributed training and inference maybe works, training definitely doesn't work because like it's just too slow and like it's just not going to work. Um, but I think it's like you certainly can make it work, or you can at the very least make it work a lot better than most of the current implementations do. And especially if you can find a way to turn that into a product, then it can certainly there's like a lot of potential available there. So what I've got is the chat window for you guys. Do you want to tell me a little bit about what this thing is here? Is it running on the Petals implementation?
Yeah, so this is basically just a front end. It's heavily modified version of Verba, which is Weaviate's vector store um application that they have. If you need a really like easy out of the box vector store, highly recommend. Um, but
I think I've used that
basically
before here, actually. Yeah.
yeah, but basically it's just a like an API for the Weaviate backend. But what we're planning on doing is using the inference for this, and then also we are doing distributed embeddings as well. They're not quite as important as the inference because it's almost deterministic, the embedding, so there's no real differentiator in terms of trying to like get web3 people to mine it or whatever. It's basically is your computer on,
Yeah.
and it'll go.
Right.
But what it is that we can start collecting large amounts of data and embedding it, and then creating knowledge stores. And we want to have distributed knowledge stores that are held in another system called uh, 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 what is it? It's file. I think Filecoin is the name of it.
Yeah,
And
IPFS maybe.
yeah, IPFS. Yes.
Hmm.
So that's based on the libp2p architecture as well.
Yes.
So then we can have um, like uh the whole big idea for like the in the long run is like get inference working, get vector stores working, get distributed training working, have hot swappable LoRa's, and then start using the blockchain itself to actually create AI layers that it builds into the blockchain, and then have the whole thing as one giant distributed AI network. But
Oh
that's
yeah.
going to take a
Yeah,
while.
yeah, no, eventually we'll get there down the road. But I noticed, yeah, what model are you running on this system, and like how many tokens a second are you getting?
So we're running a model called Sauerkraut. Our researcher basically just picked one out of the hat, out of a hat. We haven't optimized it for the other models. We still need to do the templating system because we want to implement another model, but doing so once doesn't make sense. And so we're just going to template the whole process out, but it's not it's not like straightforward. Like you can fill it out and do the forms and whatever, but like um because you need to break up the model architecture, you need to actually like understand the model quite thoroughly. So we're working on that still, but right now it's Mistral 7B is the one that's running on this.
Yeah, I'm actually curious on that. I don't know if this background music is coming through or not, but there's a very loud car outside my window. My apologies. There was an interesting thought there that I had that I'm trying to remember. Um, where so you oh yeah. So you're working on a templating system, and I remember that what we've gone over previously is that you kind of, for any model that you want to run on this sort of like distributed petal system, you kind of have to re-rig the whole architecture so it's going to fit into this kind of distributed system. If my
Yeah,
understand,
you got to break up the discrete blocks is the biggest part of it.
Gotcha. So like basically for every kind of model architecture like it's gonna need a like
Yeah, so you
some
need one for llama, you'll need one for Mistral, you'll need one for like they have Beluga, I guess is one of their models, and like
mhm.
each one you'll need your own implementation. So we're trying to figure out a way to like automate that process so that it can just like take new models without having to go through that arduous process.
Interesting. Yeah, because that reminds me of sort of the Olama model file, right? Where you have
Hmm.
to sort of define it a little bit. But in this
Yeah,
case,
it's
yeah.
very similar, but like in this case, you actually have to know the architecture quite thoroughly.
Yeah, yeah. So basically, the idea would be to sort of build. So, like for Olama, they have a model file, and the end user just sort of writes the model file, and then the templating engine that they have will go, do whatever needs to be done to that model, quantize it or whatever, and to get it running essentially. So, the idea behind what you guys are trying to do right now is to have a similar kind of system where you can just sort of like have a model that is from some sort of predefined selection of architectures, and then be able to, if the model is based on that architecture, run it through this sort of templating engine, so you can just like start using it in a
Effectively,
distributed way.
yeah, basically what you just said. So like using like the quantized GGUF architecture, or like I guess it's not, is that an architecture? I don't know what it is, but like,
Mm.
anyway, the format of the model that gets quantized when you run it through the uh, Llama CPP. Um, but we're just trying to like re-implement it in Rust instead of using Llama CPP.
Mm. Checks out to me. Let's see. Yeah, I'm trying to think. So we started at libp2p, and that's getting us across blockchains and across different communication protocols. WASM. I think I saw something on their website like WebRTC, and like testing all of the implementations across transport, secure channels, all that good stuff.
Hmm.
So like communications over here, then we get up to Petals, and this is where we're getting into like our distributed inference. Are you guys working on with training at all? Is that something you guys are exploring?
Yeah, that's like in the back burner, but
Hmm.
I do want to work on that because see a lot of value, and also just I want hot swappable auras.
Yeah.
For some reason, I think of them as little hats, and then you like switch which hat the AI model's wearing, and now it's a doctor, and then now it's a lawyer.
Absolutely. No, I think that that totally works, and especially if you can find a way to get that, yeah, like turn the whole internet into the largest hat tree in human history. That would be cool. Um, and then yeah, when I was talking to Mike earlier, the sort of progression was kind of libp2p over to Hivemind, which lets you kind of get started with. Is Hivemind inference, or is it
Hi- Hivemind is like the one of the communications layers.
okay, got it. Decentralized parameter averaging. So this is where are we at? We're at like we got about 15 minutes left. There is we have a trained neural networks of arbitrary size. So it looks like in theory Hivemind can tolerate training in terms of being a PyTorch extension that
Yeah,
can in theory
there's
do
if
it.
you look up I think it's flower
Yes. I have Flower pulled up
That's
as well.
that's an implementation of it as a distributed training. So like I know it's possible. I just haven't looked into the actual architecture of it.
Yeah, yeah. So there is some interesting stuff with Flower, yeah, which is they have a really like they're sort of leaning into it on their marketing, but it's like it works. It's pretty friendly. They'll kind of like walk you through step by step of like, okay, here's what you got to do with machine learning. Um, and then like we have like this somewhere else is many places. Like this is the kind of language I need in my docs to help me follow stuff. Um, but this will probably implement, and let me switch over to my Zotero, which is going to be here somewhere. Do I have to click this first? And then maybe it will. Yeah. Okay. So this is in terms once you get into training, and I actually need to check if I have Hetu MOE up here. I don't know that I do. Yeah, I don't, unfortunately, but that's another paper. Um, there's some other ways to approach kind of the training problem where yeah, I think there was a mention of DeLoco and DePaco, which are two methodologies um,
Yeah,
that
Doloco is training, distributed training as well. That actually was really good. I've used it before.
oh, you use when you say you used it, like what
Oh, just
implement?
like me playing around with stuff. Yeah, it wasn't anything. Not in any major projects or anything.
Well, yeah, because like as far as I know, I didn't like when I went to papers with code, I didn't find a repo for this. So is this just
Someone
sort of
did an implementation of it. I think it's called Del Taco. Um,
glorious, glorious?
yeah.
I will have to go take a look at that. But yeah, so to me, what was something interesting about this is that like so the distributed training optimization algorithm. It's a variant of federated averaging, where the number of inner steps is large, the inner optimizer is atom W, and the outer optimizer is Nesterov momentum. I don't know what half of those words mean, so something
They're
like
talking about
this.
like the optimizer. So basically, you're using a an adjusted algorithm to do the loss calculation. And so it's called like momentum because it actually like if you graph it out on like a 3D space and look at where the training is on the manifold, it effectively looks like it has momentum because it leaps forward and then can overshoot sometimes, but like it basically it makes it easier to find the global minimum when you're doing your training so that you get the best quality responses from your model. And it does it in a in a more direct and fast route than just running back propagation. So the different equations that they're adjusting are the different implementations that they're referring to in terms of atom and the momentum one.
Gotcha. Yeah, I think that maybe will make sense to me after I chew on it a little a little longer. But that we have
There's a
a
really good video of it. I'll
oh
send you
really?
the link.
Yeah,
Yeah,
yeah.
yeah,
Shoot me the link. That would be dope. Or yeah, post it in chat so other people can watch it if they want to.
yeah.
But yeah, so we have a couple of different methodologies where that have various restrictions. I know one of the things with DeLoca is that you need a uniform compute topography, which is why DeepMind is doing it the way that they are doing it because they have in a bunch of data centers that are not centrally located, but they have a bunch of TPUs and all of them have the same architecture with like uniform amounts of compute, so they're not gonna. The only thing that they're gonna have to account for is latency between peers, as opposed to peers being able to actually do the work faster than other peers, which is not something that an architecture like uh, Petals or like that's a problem that Petals has to deal with that Deloco doesn't. Is one of the things that comes to mind with me about that. Um, the yeah, so we have some optimizers explained over there. I think this one is actually pretty. Oh man, is it June already? Dear Lord, time flies,
Yeah.
man. um, so yeah, we have like another one, distributed optimization and learning. So this sounds like it's another training framework. So we are, in this case, reducing the communication frequency and compression. So bit streams are sent instead of full dimensional vectors of floats, which is interesting to me. Large class of unbiased compressors that includes widely used sparsification and quantization method. Provably benefits from local training and compression and enjoys a doubly accelerated communication complexity. Let's see. In the general heterogeneous, which is okay. So heterogeneous is like irregular, which is interesting to me. Um, and then yes, as far as I can tell, so we do have distributed optimization here. Um, and so we have sort of another approach of like basically the issue is normally we need to sort of math at these gradients in a very rapid manner, and the way that we're trying to address that here from like the super 30 seconds of reading that I've done is like, okay, we're rather than trying to do the whole vector at once. We're just going to have everybody stream what they're working on, compress it as best we can, and then kind of just shove it in there and hope it all works. Seems like it does, apparently. Um,
Yeah, it's just not very fault tolerant.
hmm.
Is the big problem with it.
Yeah, I could definitely see that, especially if you're doing that compression. Like if you drop, you drop a packet or two, you might be screwed,
Hmm.
which would not be great. Um, the other one that I am quite interested to see how it comes out is sort of another. So we covered petals, and then the iteration on top of that is flower, which is the sort of more friendly PyTorchy kind of one. And then on top of flower, we have somebody who recently claims to have built something called pollen.
Oh
Um,
yeah, I heard about that.
yeah,
They're
yeah. So this
saying that
is
they've like just they've unlocked the world.
yeah, yeah. So this paper makes some pretty ambitious claims, where yeah. So if the abstract over here is it's a privacy-focused machine learning paradigm that trains the models directly, but current simulators can't emulate large-scale systems. Which is so we solve that problem by proposing pollen, and it solves the problem of communication inefficiency, bad load balancing, push-based client, adaptable scheduling. And after we solve all of those problems, then we actually get better performance on distributed GPUs than we do if we put all the GPUs in the same place. Um,
Yeah, I have to try
which,
it out because
yeah,
I have
which
a hard
seems
time buying
completely
that.
impossible to me and totally off the wall. And so immediately when I heard this claim, I went, "Where's the code?" And they said, "It's coming. We'll release it soon." And in going through the paper is very similar to the abstract, where they go, "This is a problem, and this is a problem, and this is a problem, and these are why these problems exist. But we fixed them. Trust us, bro." So I am interested to see how it turns out. But the framework on which it is built, which is Flower, um, sort of it's like it's kind of the petals of training where the idea is like, hey, we're going to provide you a baseline architecture, and in terms of doing federated learning in a distributed environment, like it works. That's what we can say, is that like it works. Here's how to run it. Here's how to like initialize the PyTorch module or whatever. Um, so presumably, if what you guys are doing is, well, what if we took Petals and then made it not suck and rewrote it in Rust, and ended up getting something useful out of it? Perhaps these folks have done something similar, where they have taken, flower from Torch and Python and all that stuff, and done some optimizations where they made it work. I think claiming that it actually is like the best like learning framework ever before is something that I'm highly skeptical of, but um, yeah, I will sort of reserve my judgment on that for a while. Although I haven't heard of these two, Fed Scale and Flute. I'm gonna want to look into those at some point. Um, and then yeah, so we've got last 5 minutes. The other stuff that I have are deep speed MOE, but I think the paper I actually want is Hetu MOE. But they are both uh, even older methods of petals. But the interesting thing there is that when you're doing inference at scale, and you have the problem of the peers needing to wait for the slowest one, a way to mitigate that is using what we sort of in Gen AI have found is like an effective way to do inference, which is the mixture of experts pattern. So you can, if you distribute those experts across all of your available peers, and then you have a group of peers uh, um, that like is able to perform this task sufficiently quickly and such that you can complete a response from an expert, you might be able to like cut some corners and skip the slow guys if you only need to activate like a certain number of parameters in this run, which sort of like makes sense to me logically. um, but yeah, so that's like another angle worth exploring. But what I thought I would do for these last couple minutes is see if anybody had any questions, and then double check in with Mr. Baco over here as to if there's anything that you didn't get to cover that you wanted to jump over to real quick.
Nothing in particular. Yeah, sorry, I was woefully unprepared for this.
You could. Yeah, this whole thing was like an hour of me googling, and then Baco realizing that we had a presentation a couple minutes prior to. So hopefully it was tolerable and ideally educational. But I'm not going to get too ambitious with my claims here.
Yeah, I
Um,
thought this is a good overview of all the different ways you guys could do distributed training, and we also had a few papers in here too. So for something last minute, that was really good.
Yeah, so it's a topic that's just interesting to me because yeah, I always get kind of contrarian when, folks who are way smarter and better at the thing than me go like, no, you just can't do it that way. Then my assumption immediately is to go, are you sure, smart person? Let me go find everything that everybody's ever tried, and hey, look at this other thing. Did you know about that? Um, so and I think it's just important in terms of the kind of, I don't know, ethos that's important to me, where like essentially sooner or later like compute is going to have to be a human right, so we're going to have to like find a way where we can all like throw our GPUs in a pile and make sure that people can like access models so they can like do anything, presumably if the scaling laws continue to hold, and
Well,
people
it's one of
continue
the
to
reasons
leverage
that
them.
I think I have some hope for the Web3 stuff is because it's self-funding, so in theory you can offer that service. Um,
Yeah, that is also also a reason why I've been one of the Web3 guys too, where it's like I think that yeah, having programmatic incentive layers that are to some degree permissionless, and you don't have to rely on like a governing body to enforce them. You can just sort of like write the code and make it happen. Is definitely part of a piece of the puzzle. So yeah, I guess that seems like a wrap to me. And doesn't K-Ball usually spend a little time at the end trying to figure out who's up next? But no, we have
We
Sebastian's
have a
already. Yeah.
manual next week.
Oh yeah, Manuel next week, and then we
Yeah.
have Sebastian after that. And as far as I know, I believe both of them are far more prepared than I was today. And they have been. I know at least Sebastian, and I know a little bit of what Manuel has been working on. But they are both very very exciting. So you should definitely like swing by and
yeah, Sebastian's
take a
working
look.
on some cool stuff.
Yeah, it's gonna be really, really cool. But yeah, I guess with that we can call it a wrap and say see you next week. And thank you for my small audience today. But that's our bad. We got to figure out the Luma thing. But
Yeah.
hopefully you learned something that you can take with you.
Awesome. Thanks, Jackson Baco. All right. See you guys next week.
All right, see you
Cheers.
later,
Thanks.
everybody. Cheers.